Solving systems by substitution. So I'm going to do one of each case, and hopefully that's going to be enough. So it says solve the following systems by substitution. And this is a little comment here. Substitution is best used when at least one equation is solved for a variable. And it says write final answers as an ordered pair. So let's just jump into it. So case number one is when both equations are in the form of y equals mx plus b. So like it said up there, we need at least one equation, or we would like to have at least one equation that's written as either a y equals or x equals. And the fact is on this case one, both of them say y equals. So that's helpful. So what we can do is we can take, since y equals, I'm just going to take I'll take the first equation. Since y equals 3x plus 13, since y equals this that I'm circling, since y equals that can go in for y on the other equation. Okay, because that's what y equals. Y equals 3x plus 13. So by that equality, I can put that in for y in the other equation. So my new sort of equation that I can write out, I'm going to put that 3x plus 13. I'm going to substitute it in for that y there. So I'm going to have 3x plus 13 where that y is. That's what I just did. I put it there. And then I have this negative 2x minus 7. So that's called substitution. So I've substituted what I know y to equal into y in the other equation. That's substitution. And then you just solve it. So I'm going to solve it. Okay, I might not show full steps here. So I'm going to do plus 2x. I'll show most of the steps. Okay, so this is going to be 5x plus 13 equals negative 7. And I'll just show all the steps. Then I'm subtract 13. 5x equals negative 20. And then divide by 5. X equals negative 4. Okay? So x equals negative 4, but I'm not going to circle that because in order to solve the systems, I can't only figure out what x is, I also have to figure out what y is. But figuring out what y is actually becomes an easier exercise because I have x. And I actually have two equations to work with up here. I have the equation y equals 3x plus 13. And I even have that equation y equals negative 2x minus 7. So I can use either of those equations to figure out what y is. Now I'm going to use the first one, the 3x plus 13, has less negatives in it. So I'm going to use that. So I'm going to take that negative 4 and I'm going to substitute it in for x, because that's what x is, to solve for y. So I'm going to write y equals 3. So it's 3x plus 13, but x is negative 4. So I'm going to put a negative 4 in there. Let me just, I don't know, bold that or something. Plus 13. So I took, let me highlight that. I took this, I put it there. So then y is going to equal 3 times negative 4 is negative 12. Negative 12 plus 13 is 1. So y is 1. So there you have it. I've solved the equation. X is negative 4. Y is 1. Now it does say write your final answers as an ordered pair. And you might not know exactly what that means. Probably from last year, you kind of solved systems by graphing. So an ordered pair is just like the coordinate point. So if we list our coordinate point, remember our coordinate points go x, y, would be negative 4 for x, 1 for y. That's how it wants us to write it, as an ordered pair, or x, y ordered pair. Okay, so that's case one. So if you need to rewatch that. That's the only example I'm going to give for case one. So case two is just when one equation is solved for y. So in that last example, both of them were y equals. This one, only one of the equations is solved for y. So in this case, what I have to do, if y equals 2x minus 5, or sorry, 2x minus 5, what I can do, since y equals this, I'm going to circle it again. So y equals this. I can substitute that in for y on that equation. And this is how it's going to look. I'm going to start rewriting that equation. It's 2x minus 3. Where the y is, I'm going to put the 2x minus 5 equals the negative 9. So I just rewrote the first equation. It was 2x minus 3y equals negative 9. I rewrote that equation. But where y was, I substituted the 2x minus 5 in for it. And now we just solve. So I'm going to distribute. So 2x, now remember that's like a negative 3. So negative 3 times 2 would be negative 6x. And then the negative 3 times the negative 5 is going to be positive 15. Now I can combine some like terms, the 2x and the minus 6x. That's going to equal negative 4x. I have a two-step equation. Now, I'm not going to show full work anymore. So I'm going to subtract 15 from both sides. We've done enough solving equations. Subtract 16 from both, or 15 from both sides. So I'm going to have negative 4x equals negative 19 minus 15 would be negative 34. And then, oh, why did I write 19? Sorry about that, guys. Hopefully you caught you kind of thinking, what the heck? Why does he have 19? It's 9, just negative 9 here. Negative 9 minus 15, I think that's negative 24. Divide by negative 4, x is positive 6. And then since I have x, I still need to get y. So I can plug it into either equation up there, but it's easiest just to plug it in that second one where it says y equals 2x minus 5, because that's just easy. Y equals 2x minus 5, so I just need to do y equals 2, plug in 6 for x, minus 5. So y is going to be 2 times 6 is 12, minus 5 is 7. So as an ordered pair, remember x goes first, y goes second, 6, 7. Okay. Make sure you see what I did there. All right, so just, so on this one, you're going to take this and you're going to plug it in there, substitute it in for y on that. Case 3, where one equation is solved for x. So this is very similar, except just one equation is solved for x. So since x equals negative 3y plus 1, I can take this negative 3y plus 1 and substitute it in for x, because that's what x equals. You wouldn't substitute it in for y, you substitute it in for x because x equals that. So I'm going to write this out. I got my 4. Now where x is, I'm going to write the negative 3y plus 1. Then I have that plus 11y equals 2. And then we solve. So distribute. It's going to be negative 12y plus 4 plus 11y equals 2. I can combine some like terms. Negative 12y plus 11y would just be negative 1y plus 4 equals 2. Subtract 4 from both sides. Divide by, now remember that's a negative 1y, so to just get a positive 1y, I need to divide by negative 1. So y is going to equal 2. Now to get x, I'm going to substitute the 2 for y. So I'm going to use that first equation because it says x equals negative 3y plus 1. That's going to be easy. So x is going to be negative 3. Y we know is 2. Plug in 2 there. Bold that. Plus 1. Okay, so again, I'm just taking the 2, putting it there for y on that first equation. And then that's going to be negative 3 times 2 is negative 6. Negative 6 plus 1 is negative 5. So now be very careful with these ones because make sure you list your coordinate as x, y. So x is negative 5, y is 2. A lot of times people accidentally put the 2 first on this one because that's the answer they got first. But remember, all coordinates are x, y coordinates, so x needs to come first. Okay, one more example. So just so you know, on this one, you're going to remember this is x equals y minus 7. So that's going to go in for x as you do that one. Number 4 would be a word problem, okay? So here we go. Amir spent a total of $53.75 on breakfast sandwiches and bagels for his friends who are visiting from out of town. Each breakfast sandwich cost $4.25. Each bagel cost $2. He bought 5 more bagels than breakfast sandwiches. Okay, so A says write a system of equations that could solve for the number of breakfast sandwiches and bagels. Okay, Bagels and breakfast sandwiches. So it kind of stinks because they both start with B. So I'm trying to like pick variables here. I'm gonna say B is the bagels. Okay. And then I'm gonna say S, and that kind of stinks because S's look like 5s and B's look like 6s sometimes. But S is the sandwiches. Okay. Okay. Each breakfast sandwich. So this costs $4.25. So $4.25 times the number of sandwiches plus $2 for bagels, it says. So 2B equals a total of $53.75. So this first equation I kind of like to call my money equation. It's $4.25 per breakfast sandwich, so 4.25 S. And then it's $2 per bagel, so 2B equals $53.75. But then this second statement says this. He bought 5 more bagels than breakfast sandwiches. He bought 5 more bagels than breakfast sandwiches. So the bagels would have to equal the sandwiches plus 5. Because he bought 5 more bagels than breakfast sandwiches. So this would be the setup. And then B says solve the system. So if bagels equals S plus 5, then the S plus 5 can go in for B because B equals S plus 5. So I'm going to have 4.25 S plus 2 S plus 5 equals 53.75. So I'm going to have 4.25 S. I'm going to distribute the 2. That would be 2S plus 10 equals 53.75. I can combine some like terms here. This will combine with this. So the 4.25S plus the 2S would be 6.25S plus 10 equals 53.75. Subtract 10 on both sides. I'm going to have 6.25S equals 43.75. Divide by 6.25. I'm going to get out a calculator. 43.75 divided by 6.25. I got 7. Okay. So S is 7. The sandwiches is 7. Now I just need the bagels. And I got a very super easy equation for the bagels. The bagels is just S plus 5. So the bagels is S is 7. So 7 plus 5 would be 12. And there you go. Now, it wouldn't make any sense to write this as an ordered pair because it's just a word problem. So I'm going to say S was our breakfast sandwiches. So I'm going to say 7 breakfast sandwiches and then 12 bagels. So I'm just going to write that out. Okay. So that's a word problem. So I'll let you do the rest of this lesson.